Welcome Geometry. I have a really fun project for you planned after class today. Let's talk real quickly about Mod 5 coming up here. It's about transformations. We're going to look specifically about transformations of figures and points on the coordinate plane. So that's kind of dipping into what we call analytic geometry. But today we're just going to cover the very basics, what a transformation is, what are a couple examples, and we'll get some vocabulary defined here. So transformation is just a function that changes the position, size, or shape of anything. Could be a figure, could be a shape, could be a segment, could be a graph, all right? So that's just the basic transformation definition here. For example, we have this one over here, so we've got this nice little diamond shape, and we have transformed it. Well, first I can tell you a couple things. It definitely moved this direction, all right? And I can see that it probably rotated, and it got a little bit bigger. So we scaled this thing up. There's a whole bunch of words, and they're basically very similar to like rotate and dilation. We'll go over here in just a second. But if this was our original figure, whoops, that's Q. If this was our original figure, this is what we call the pre-image. And if this is our transformed figure, that is what we just call the image. So when I refer to pre-image and image, we got to know exactly which one was, which one got a function applied to it to change it, all right? So a couple definitions there, image, pre-image. You may want to get a little sketch of another shape that you wrote down that changed, all right? Okay, underneath the umbrella of transformations, we're going to talk about rigid and non-rigid motions. And chapter 5 is going to focus more on the rigid motions, but I do want to describe what exactly these mean. So I know there's a lot down here, but just bear with me. So rigid motions here do not change the size or shape of a figure. They preserve the distance between points, angle measure, collinearity, which just means that points that are on the same line are still going to be on the same line. Actually, I'll go ahead and add that in here. Points on same line. And also betweenness, which just is a word to describe that if point B was between point A and C, after you do a rigid motion, point B is still going to be between A and C. All right. Some examples of rigid motions would be translation. So translation just means to move. And we'll get more exact definitions of these later. But I just wanted to find a little bit what they are. So translation just means to move. An example of that would be, here is a triangle. If I take that triangle and I move it this direction 8 units, still going to be the same triangle. It didn't change the size, shape of my figure. It just moved around a little bit. Rotation is just what you think about it. You're rotating around a point so many degrees. So maybe you've got this smiley face here, and you want to rotate it around this point 90 degrees. Well, let's say we rotate it clockwise. Now that smiley face is going to kind of look like maybe this if I had to sketch it out a little bit. All right? So rotating around a point. Reflection, I don't know how to define these other than just it's reflecting across, I did not spell that correctly, across a line. So let's say that you've got this line of reflection and you have a heart over here. Well, reflecting it, it's going to look a little bit like that, obviously. All right. Again, we're going to get more concrete definitions as we go through these because we're going to start applying them to points on our plane. So take a second, make sure you've got a couple definitions of translation, rotation, reflection. You know what it means to be a rigid motion. Okay, non-rigid motions, on the other hand, are things that don't change, are things that do change size or shape. So, for example, if you had a dilation, so maybe I was going to draw a car, but that sounds too crazy. How about another triangle? If I do a dilation, that just scales something up. See how it changed the size? May not have changed the shape, but this thing got bigger, so this is considered a non-rigid motion. All right, so dilation, or you could take this thing and scale it down by a factor of maybe 1/5, and you'll get a really tiny triangle, right? So dilation, I like to think about it as scale by a factor of blank, right? Could be multiplying by 2 and then everything gets bigger, or you could multiply by 1/4 and everything gets 1/4 the size. Okay, vertical stretches and compressions, horizontal stretches and compressions. The best way that I like to explain this is you've got a circle. If I wanted to stretch this vertically, its horizontal distance here isn't going to change, but everything is going to get stretched out this way from the center. So if I stretch something vertically, that horizontal distance isn't going to change, but everything got stretched out from the top and the bottom. Or if you want to do a vertical compression, we could take that circle. Again, this kind of idea of the width, the horizontal distance isn't going to change, but vertically, it's going to get compressed into a smaller little oval there. Again, we could think about this as the horizontal distance didn't change, but everything got pressed down. Same thing with horizontal stretch and compression. I'll do a square this time. If I wanted to stretch this horizontally, well, the vertical distance, right, the height of this thing isn't going to change, but everything is going to get stretched out this way. So while that height didn't change, my square kind of ended up being a rectangle because everything got stretched out to the side. A horizontal compression would be, here's my little square again, that vertical distance, the height is not going to change. But if I try and compress it to make it go smaller, well, that square is going to get a little thinner there since it all got pushed in. Okay, that was just the basics. We'll get more information about that, but definitely make sure you understand translation, rotation, reflection, and dilation. Get a sketch of any of these if you need to, and I'll see you in Blackman 107. Have a great day, you guys. See you soon.